Unit 1 is all about data and the data cycle, and this is a quick 1-hour revision session, 45 minutes. Please remember that the content for Unit 1 covers fractions, decimals, percentages, ratios and proportions. These are all topics that we did under Unit 2, but they become a lot easier in Unit 1 because you can use your calculator. There will be questions on these topics, like standalone questions on percentages and so on, in this paper. So if you are asked to work out a percentage of something or a fraction of something and the numbers are nasty, then use your calculator. You don't have to show all your working out with respect to how you multiply two numbers or divide numbers. Okay. We're going to cover specifically today then the stuff in brown: the data cycle, collecting data, representing data, statistic measures and probability. So what's it all about? It's all about the data cycle. Step 1 of the data cycle.
Hypothesis.
The hypothesis, or what's the problem. Step 2. Collect the data. Step 3.
Process.
Somewhere. Step 3. Process and present it in some way, either mean, median, mode and range, and then discuss and interpret your data. Every paper you will get a question that involves you talking about this data cycle with something. Okay? You'll have to put it in context, like your homework, where somebody said, oh, is the average wage gone down? Where you'll have to go through the stages. Almost every paper will have the data cycle where you've got to talk through those stages. So keep that in mind. Okay, the types of data then. Anybody remember any of these? Raw data?
Primary and secondary. Primary is where you've collected it.
Good.
And secondary is like you get off the internet.
Brilliant. So that's primary and secondary sorted. What's raw data? Sorry? You haven't done anything with it. It's just coming in, you know, email shots or as you're collecting it on a questionnaire or whatever. Quantitative and qualitative.
One's doing numbers, one's doing letters.
Which one's numbers?
Quantitative.
Quantitative is numbers. Qualitative is letters. Okay, so quantitative numbers, qualitative, think touchy-feely stuff. What colour's this? You know, how do you feel about that? Quantities, or quantitative, splits into two other subcategories, discrete and continuous. Anybody remember what discrete and continuous were?
Continuous like 1, 2, 3, 4.
Discrete was like half of something or a point of something.
Ooh, close. What examples do I normally give with discrete?
Like temperature.
That's the other one.
Oh.
That's continuous. Continuous data, temperature, height, so length, temperature, length, time, and weight. So the things that we round because it's easier to do them. Discrete, John, is the number of people in a room. Scoring a goal. Okay, discrete things. Shoe sizes, 8, 8.5, 9, 9.5.
So
okay.
Discrete is like whole numbers.
Not whole numbers, 8.5, 9, like shoe sizes.
So what's
discrete.
Continuous?
Continuous are things that we deliberately round. So continuous data is time. And if I said, oh, how long did it take you to do the 100 metres? 10.1 seconds. It isn't 10.1. It's 10.1348763824824. And we just shorten it, round it to 10.1. Okay?
So continuous is stuff that's been rounded.
Yeah.
And discrete is?
Set numbers, like shoe sizes, 8, 8.5, 9, or scoring a goal, the number of people in a room, the number of sheep in a field. And we've got grouped and ungrouped data. Okay? There's some pros and cons for each. Group data, what's an advantage of grouping the data? Anybody remember? Easier to collect, yeah? It's easier to get together, but when you group it, what do you lose? The accuracy. So keep that in mind, okay? When you see grouped data, you're losing some of that accuracy. Okay, so the methods of collecting this data then. So we're at stage 2 now. Anybody remember how we collect data?
We watch it, we actually see a car, you write it down.
That's observation.
Questionnaires and surveys.
Questionnaires or surveys, and then the one that we did last week, brilliant, experiments, rolling that dice. Okay, they're the 3 main ways that you collect information. So when you're talking about your data cycle and they're asking you to solve it, say collect the information through an experiment or through a questionnaire or observation. When you're doing questionnaires, you should think about these things. It needs to be short, it should avoid personal information, give options, easy to understand, test beforehand, relevant, and it needs to be fair, avoiding this word called bias. Anybody know what bias is?
When it favours one thing.
Good, when it favours one thing over another. And that favouritism could appear in stage 1. Like if we decide to do the average house prices in Lancashire, when we're doing our planning stage and we decide to go and ask people in Lytham St Anne's, you're not going to get a fair response, are you? Because it's far more expensive than anywhere else around here. Don't forget, biasing can also be in the question. For example, Derby County are the best football team in the world, aren't they? And it's trying to encourage you to say yes. Or even the people you're asking, like the questionnaire in Lytham, you know, the poshest houses are on the front. So think about bias and where biasing can occur. Okay, so we're now into organising this data. So we've done stage 1, we know what we want our data for. We've done stage 2, we've collected it, and it's come in its raw format. We can order it in an ordered list. Generally, they won't get you to do ordered lists at GCSE level because it's just sorting numbers, okay? And it's sort of a Unit 2 type question. And it's more to do with spreadsheets when you get lots of numbers and you have to put them into a particular order. What you're more likely to get are tallies, groups, and two-way tables. We've already talked about groups where information can go into the groups. So if I'm collecting data at the college on the average age of students, and as they're coming into the college, I'm asking their names, and it goes 1 to 10, 11 to 20, and so on. If somebody says they're 15, then I know which group to put them in. Does that make sense? Okay, just in case there's a question like that. Tallies. What's the advantage of a tally?
It's easy to count.
It's easy to count, but what's the main advantage of doing this tally? Anybody remember? It was quite a little subtle thing. It does stage 2 and stage 3 at the same time. You can use a tally to collect the data, and as you're doing your tally, you can actually see the progress as you're going along. So you can actually tell, you know, and you'll see a tally in a minute, that the favourite flavour of butter is buttery spread or whatever. And then finally, the last way to organise the data is in two-way tables. And we'll have a look at a two-way table in a minute. So in mathematics, specifically in Unit 1, we have this word, frequency. Anybody remember what the frequency stands for?
Like, so you've got like a tally chart, you've got like the numbers.
Yeah.
And then like you add whatever you've tallied up.
Good. So the frequency is a posh word in maths for a count. Okay? So when it asks for a frequency in one of your columns, you're meant to put in the number 6, 7, 8, okay? It's not a tally. The tally is to the left. It's a separate thing. The frequency is the box at the end that adds them up. So the frequency is the total or the count. Okay. So let's have a quick look at two-way tables. If you get a two-way table, generally they'll miss out some information on that two-way table and ask you to fill it in. So in this example, we're looking at the number of boys and girls in various years in a school. Obviously, I can't work out how many boys and girls are in year 9 because I don't have enough information yet. So the way to tackle these things is to do the obvious things first. For example, I know the total of year 10 and I know how many girls, therefore I can calculate how many boys. And two-way tables are quite straightforward and will be like that. Then we move on to stage 3 proper. And we had all these data displays that we did a couple of weeks ago. Tally charts, bar charts, pie charts, similarly, pictogram, line graphs, frequency polygons, scatter graphs, and histograms. Okay? And you're going to probably be tested on most of these in the course of today.
Write them down.
That's going to take you a lot of time to write them down.
Okay.
We'll do one at a time. We're going to go through each one at a time. So the tally then. The tally does what it says on the box. It does stage 2 and stage 3 at the same time. So I could create a tally while I'm collecting the data as people are getting off the bus and asking them for their favourite flavour of butter. The thing about the tally is this thing called the 5-bar gate. So if they ask you to complete a tally, remember when you get to the 5th one, draw that line across. And it groups them into sets of 5 so you can count them easily. Okay? So you might have to complete a tally. Okay? When you've done that, you then put in the frequency, which is just the totals. For here, you put 4, there you put 3, and so on. So if you get an empty tally or a partially completed tally, complete it in the correct way, the 5-bar gate and the frequency at the end. A pictogram does what it says on the tin. It's pictures that represent data. So, In this case, we're talking about Smarties. We have lovely pictures of Smarties. The most important thing about pictograms...
Is that why, like, half a car could mean, like, 2 cars?
Yeah, if it was
like,
4 for a whole car,
yeah.
then half a car is 2. Very important point. So here, as Anthony says, the most important thing is the key. So half a Smartie here is 1 Smartie. So I've got 2, 4, 6, 7. Okay? Important thing is these are nice simple questions. On your homework, I think it was question 1 on your homework, it might be question 1 in your exam. If there are more than 1 mark for showing you're working out, then show how you drew 8 houses. On your homework, it said something like there were 32 houses because it was 50% of the total. And some people just drew the 8 houses and didn't show how they got from 50% of 64 to drawing 8 houses. And you need to know 64 was divided by 2 to give you 32. 4, you divide by 4 to give you the 8. So have an audit trail when you get these easier questions, okay? The next display type is the bar chart. And this is the perfect bar chart. It has our title at the top, our axis labels, it's got a scale that makes the most of the paper, and for each of our bars we have a label at the bottom. Don't label the bars themselves. Between each of the bars on a bar chart is a gap. That's what makes it a bar chart. If there's no gap, it's not a bar chart, it's another display. Don't forget the gap between the left-hand axis. So gap, bar chart, back, gap, bar chart. The bars are all the same width, and the heights represent the data they're showing. So on a Monday, there were 23 parcels that were posted. Okay? Nice, straightforward. The dual bar chart compares 2 sets of data. Now, when I gave you your homework, a lot of people were making the mistake of drawing a component bar chart. A dual bar chart compares 2 sets of data. So here I've got a set of data for year 7 and a set of data for year 10. And the idea of a dual bar chart is to compare year 7 with year 10 on each of our categories. So I can see quite clearly that year 7 prefers salt and vinegar over year 10. Cheese and onion, year 10 actually prefer it over year 7. Still got the title, got the axis labels and a scale that makes the most of the paper, and we still have the labels for each of the columns. This time your 2 columns actually touch, but you have gaps between each of the categories still. Some people were putting gaps between those 2 columns. They actually touch when you're comparing the 2 sets of data. So a dual bar chart is something subtly different to this next display, which is the component bar chart. And the component bar chart doesn't compare sets of data, it compares the categories. So here, it's not as easy to compare year 7 to year 10 with each of the flavours, because they're on top of each other. That's what you do for a component bar chart. You put one set of data on top of the other. And a component bar chart, though, tells me overall which my favourite flavour is. So I'm comparing categories. And I can see clearly that salt and vinegar is the favourite, and that ready salted is the next favourite. So it does something subtly different. It compares categories. Still got a title, still got axis labels, a scale up the left-hand side, and your categories are clearly labelled at the bottom. Okay? Good. Pie charts. To create a pie chart, everything goes into 360 degrees. So if I asked you how everybody gets into work in the morning, it's either into college in the morning, 10 people take the car, 15 people walk, and I don't know, let's say 11 people take the bus. Okay? If you've got something and you're creating a bar chart, then whatever you're putting into the bar chart, in other these people, have to go into 360. That's the key of drawing a bar chart. So here, I've got 36 people.
You mean a pie chart?
Sorry, pie chart. Thank you for correcting me. So everything has to go into the pie chart, into 360 degrees. So if we've got 36 people here, and we're going to put them into 360 degrees, then we divide 360 by that 36. This is the frequency count, yeah? We've taken our tally, we've put the frequencies down. It's 10 degrees per person. So you go back to your frequency count and multiply each one by 10 to tell you that cars is 100 degrees, that the people that walk is 150 degrees, and the people that catch the bus is 110 degrees. You then go to your pie chart and you draw 100 degrees, label it as car.
So one person is 10 degrees.
One person, that's what that tells you. So you know you've got 10 people here, so 10 times your 10 gives you 100 degrees. Then put your reference line on and go round to 150 degrees, label it, and so on.
Do you have to have a key for this one?
No, because you can write B, C and W inside the pie, and that's good enough. Don't worry about shading and keys, and that takes time. Okay? Now, drawing a pie chart is subtly different from reading things that are divided into a pie chart. So if I gave you a pie chart and it was like that, and I say that number of people catch the bus, it's got nothing to do with 360 degrees. What is that as a fraction?
A quarter.
A quarter. So if I say 100, we surveyed 100 people and a quarter catch the bus, then 25 people catch the bus. The number 360 isn't used anywhere, is it? Because you're now looking at the pie chart as a fraction. And that goes for percentages. If I said I've got a pie and 40% of my pie is the news of the world and 50% is the sun, and I say to you, we surveyed 1,000 people, how many people read the news of the world? It's nothing to do with 360, is it? It's saying news of the world is 40%, so it's 40% of 1,000. So that means 40% is 40 over 100 times the 1,000. Yeah? And you know it's 400 people. Okay? So don't get confused with this 360. The 360 degrees is to do with you drawing the pie chart. Once the pie chart is drawn and labelled with either a fraction or a percentage or whatever, then it's back to Unit 2, dealing with a fraction or a percentage of an amount. Yeah? Happy? Really happy? Okay. Okay. So, stem and leaf diagrams then. Stem and leaf diagrams do what? What's the purpose of it?
Make it easy to read.
Easier to read, it sorts the data, okay? On the left-hand side we have tens, on the right-hand side we have units, and it makes it really easy to organise those units. So you have an ordered stem and leaf. If you have a key, make sure you put a key in there, okay? The key's always worth 1 mark, and it states the blindingly obvious. 2 bar 5 means the number 25. 2 bar 5 is the number 25. Line graphs. We did line graphs in Unit 2, and you're just plotting one thing against another. So here we've got the title, the axis labels, decent scales that make most of the paper, and we're plotting the time in minutes against the temperature of a kettle. See how a kettle boils, okay? And when you've got, after 1 minute, it's 24 degrees, put a little cross there. Don't put dots. Because if you plot a line graph and put dots and then join the lines, the dots tend to disappear and the examiner can't see why you're drawing that line where you're drawing it. So when you're drawing line graphs or anything that you're plotting, put a little cross there, get into that habit. Okay? Quite straightforward, nothing to worry about. You might get asked to read line graphs. So if they said to you, what temperature was the kettle at 4.5 minutes, go to 4.5 minutes, go up, read across, and it's 56 degrees. Okay? So you might have to read a line graph. That's quite straightforward. Generally, you won't have to draw a dual line graph, but you might have to read one. Okay? Again, title, axis labels, scales are all lovely, labels across the bottom, and here we've got rainfall in Wales and England. And what they're more likely to do, like your homework from week 5, is give you a dual line graph and ask you to compare things within it. So if I said to you, how much more rain did England have than Wales in June, then they're expecting you to go to June, read off the value for Wales, read off the value for England, and take one from the other. So they're more likely to get you to read a dual line graph and not get you to plot one. Okay? Remember the pens problem in one of your homework, Company A and Company B selling the pens, and you had to compare which one was cheaper for 50 pens. It's exactly like that. This vertical bar line thing, okay, it's appeared in the last few papers, and it's all to do with a thin bar chart. If that's how you think of it, it's just a thin bar chart, Okay, it's got a title, axis labels. It tells you on the left-hand side the frequency of whatever's happening. In this case, the number of games played, and across the bottom, some more information about the number of goals scored. So, in 6 games, 1 goal was scored. In 2 games, 3 goals were scored. And you can work out mean, median, mode, and range from that information by multiplying one thing by the other. Happy? Thin bar start. Right. A frequency polygon is where we start dealing with continuous data. You can take continuous data because one thing goes on to the other, and it's generally grouped like that, where one thing rolls on, okay? And it's one of 2 frequency diagrams, okay? So a frequency polygon is a fancy line graph. And a frequency polygon plots the frequency against the midpoint of whatever this value is. So the midpoint of this is 7.5. So I plot a frequency of 16 against 7.5 on my time, 12.5 against 22, and so on. Okay? The other frequency diagram you might need to know is the histogram. And the histogram is the equivalent of a bar chart. But because it's continuous data, there's no gaps, they touch. That's why we're adamant you've got to have the gaps on a bar chart. So a histogram displays continuous data, and it's the second of your 2 frequency diagrams. Okay? So in this instance, the data goes from 5 minutes to 10 minutes, and it has a frequency of 16. So between 5 and 10 you draw your bar, and you go up to 16. And then the next bar along between 10 and 15 goes up to 22, so they touch. In your homework, you had a data that started at 0, and some of you drew the 0 data and stopped short of the axis label. So you had 2 zeros. You had a 0 there and a 0 there. If it starts at 0, then it goes all the way to that line. Okay? Scattergraphs. Scattergraphs show correlation between 2 sets of information. So here we've taken the maths marks and the physics marks for each student. So Joe Bloggs here got 30 odd in his maths, and he got 18 odd in his physics. And when you plot all these points out, they show this word called correlation. So in this instance, would you say there's any correlation?
Yeah.
Yes, it's what sort?
Positive.
And would you say it's strong or weak? Strong. Strong correlation, okay? So correlation can be strong or weak, and it can be positive or negative. And if you have a point out there,
Outlier.
it's called an outlier, because it doesn't tie in with the rest of the information, and you ignore it. You don't try and force your line here, which we call the line of best fit. You don't try and include it by dragging it over that way at all, okay? You ignore an outlier. If I had a single dot down here, would that be an outlier? No, because it kind of it ties in with where the line would have been heading, okay? So outliers are like off left and right of centre, not front and back, if you catch my drift. Okay. Statistical measures then. This is where we get to talk about mean, median, mode and range. To calculate the mean, you add the total of the numbers and divide by the number of numbers, okay? It's called the calculated central point. Dead easy if they give you a set of numbers. If I gave you 2, 7 and 9 and ask you for the mean, you add 2, 7 and 9 and you get 18. And you divide it by 3 because there are 3 numbers, and it gives you a mean of 6. Some questions, they're not going to just give you the numbers and the number of numbers. They're going to give you a mean and or the sum of the numbers, or how many then numbers there are, and they're going to mix this information in. So if I said to you, on average, a teacher eats, there you go, there's our fault again, eats 6 chocolates a week, okay? And I asked 20 teachers, how many bars of chocolates were consumed by all of the teachers? Well, we don't know the sum, but I know the mean and how many teachers there were. So you multiply the mean by how many there were, and you get 6 times 20, and that gives you your 120 as your sum. Okay? So it's like a little equation, but if you use that, you can cover up the thing you don't know, and it helps you out. Okay. Now, medians. There are two sorts of medians. Medians is the middle number. If you had an odd set of numbers, like the number 5, you had 5 numbers, there's one middle to an odd set. It's really important that you understand this, okay? So, if in an odd set, like 1, 2, 3, 4, 5, 6, 7 numbers there, you put them into order first, and there's one middle. So if you've got 7, divide it by 2, it gives you 3.5. You round it up, so the 4th number is my middle. 1, 2, 3, 4. It's easy to do when you have little numbers, but if I said to you there were 51 numbers in a set of numbers, then the middle number is?
27.
Good. 25.5 is a half of 51. You can use your calculators, and then round it up. Okay? Good. If you have an even set of numbers, you have a different middle, because an even set of numbers has 2 middles. Okay? So here we've got 8 numbers. Divide 8 by 2 and you get 4, and it tells you the lower of the 2 middle numbers. So 1, 2, 3, 4, that's my first middle. My second middle number is 33. Add them together, divide by 2, so 29 plus 33 is 62. Divide by 2 gives me 31. So my median, my middle number for that group of numbers is 31. Okay? So be aware of medians and manipulating medians. Medians won't just be about putting them in order and finding the middle. It might be about adding another number and the median changing, okay? So be aware of those types of questions. The mode does what it says on the tin, the number that appears most often. You don't have to sort them. Some people can spot the mode straight from the data, and in this case it's the number 23. Be aware there could be more than one mode, so 3 and 6 are both modes. Okay? Range. The range comes from the data and not the frequency, and we'll talk about that when we do frequency tables. So the range here of our data values is 8, take away 2, which gives us 6. Nice straightforward range. What does range give us? Anybody remember? If you have to talk about range in anything like you did with your homework, it's a measure of what? Spread. We use the C word. Remember we played hangman with it? Consistency. Okay? So range is a measure of consistency. So if we're talking about darts, and he's getting 100, 100, 100, he's really consistent. If he's getting 20, 180, 20, 180, he's not very consistent. So if you get a question about range, use the consistency word. Let's talk about remembering these, okay?
Wait, is range the difference between the highest and lowest?
Highest and lowest data value. Okay, a lot of people in their homework have been making a mistake of putting the range down as the highest to the lowest frequency when we do frequency tables. It's the highest to lowest data value. So hey diddle diddle, the median is the middle, you add then divide for the mean. The mode is the one that appears the most, and the range is the difference in between. Okay.
Hey, so the median, you put them all in order?
Yeah.
And then you divide by 2?
Depends. Put how many are you dealing with?
Well, if it's an odd, you divide by 2 and then round up.
Yeah.
If it's even,
Yeah.
you divide that by 2.
Yeah, and it tells you the lower of the
one
2
and then
numbers because
right.
you're expecting 2 on an even set. Okay? And you will get questions where they'll give you a median for something and add a number in, or say how do you change the median, those kind of manipulating the median type questions. Okay? Choosing the best average, because mean, median and mode are all what we call averages. Most people think that mean is the average. If you get a question asking you to say what the pros and cons are, very quickly, the mean is the most representative because it uses all the data. But the problem with a mean is it includes outliers. So we talked about teachers' wages and the principal and what she's on. One massive wage can drag everybody other's wage, mean wage, up. Okay? A median, it's easy to find when you've got ordered data, but it's not always a data value, like you saw with the 2 a minute ago. It was between 28 and whatever, and it turned out to be 29. Okay? The mode, again, dead easy to find. You don't even need to sort the data out. The problem with a mode is there can be more than one, or one that's not at all, or it doesn't represent the data. If I said our data is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, what's the mode? 1. It's right down at one end of all our data, so it's not representative. See what I'm saying? Okay? Right. Frequency tables and mean, median, mode and range. A frequency table shows you a relationship between one set of data and a frequency count for that data. So our P's in a pod, basically when you open the pod, there's going to be 3, 4, 5, 6, 7 or 8 P's in that pod when I open it. And so Birdseye have done a survey of 100 pods and they've counted how many P's were in each. So there were 5 pods that had 3 P's, which means there were 15 P's counted. So there were 10 pods with 4 P's.
So what would you call that column when the P's are in?
That's your data. So these are the numbers. So it's like if we put it into data value, it would go 3, 3, 3, 3, 3, because they had 3 P's in a pot. And then it would go 4, 4, 10 times. Then it would go 5, 5, 5, 28 times, and so on. And they've just done, this is your frequency count, or your tally. You know, at the end of your tally when you've counted things, this is just the sum, the total. Okay? So you have to go along, and you have to multiply one by the other to get this value to find out the total number of P's. Call it 84, 8 times 9, 72. And if we added them all together, and I'll make a number off the top of my head, I'm not going to add them up, it's 400. So to work out your mean, what do? So the mean number of P's in a pod.
Go divide 400 by 8. No, 1, 2, 6, yeah.
No, how many pods?
100.
100. So you calculate it by dividing your total number of P's by the number of pods that you opened. So that gives you a mean of 4 P's in a pod. Okay? The median then, and this is where our little trick comes in. It's the middle of your frequency count. Okay? The median on a frequency table comes from the middle of your frequency count. So I counted 100 pods, so what's my middle pod? What's 100, odd or even? So how many numbers am I expecting?
50.
How many numbers am I expecting for an even set of numbers? 2. There's 2 numbers in the middle of an even set. So it's the 50th and the 51st number. So where do I find my 50th and 51st number? Well, they're already in order for you. So they're the first 5. There's another 10, that's 15. Another 28 is 43. So the 50th and 51st live in here. So your median is the number 5. Yeah? Happy with that? The mode. What is the mode on a frequency table? 36 is the highest frequency. So what is the mode? The number 6. Brilliant. So don't confuse the frequency count with what the mode is. The mode is the number 6. Got that? Get it? Got it? No mistakes. Okay. And then the range. What's the range?
8 take 3.
Good. The range comes from the data. So it's 8 take away, it's gone off again, hasn't it? 3, which gives us 5. So the range comes from this, not from the frequency count. The range is the range of your data. Got that? Sure? We're finding out very soon. Okay. Okay. Let's look at median, mode and range with respect to stem and leaf. Stem and leaf is ordered information. We know these are the tens, these are the units. It's not very easy to work out the mean, so we don't use it for the mean. So if I said to you the median, how do I work out the mean? I'm going to send this video in today, trust me. If we're going to work out the median, that's what that word says, okay? What do I need to do? How do you work out the median? What is the median?
Middle.
The middle of what?
6.
Of the number of numbers we had. So if I count those numbers and I say I've got 20, what's the middle of 20? 10 and 11. There's 2 numbers in the middle, isn't there? So it's 10 and 11 because it's an even set. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So it's 5 and 8 there. So how do I work out what my median is?
Do you add them and divide by 2?
Brilliant. So I add 5 and 8, which is 13. Divide by 2 gives me 6. This is getting worse. 6.5. But it's not 6.5, is it? It's 36.5. Yeah? 36.5. Okay.
We got like, we'll just leave it as that, then she wouldn't round up.
No, don't round up. She's not asking you to round up. If that's what it is, that's what it is. 36.5. Okay. If I said the mode, which one's the mode? Sorry, Sam? Not 5. It's 35. Don't forget the 3. Okay? And then, what's the range?
60 take away 5.
Yeah, can you see that? Biggest number is 60. Take away the smallest number, 5, which is 55. On to what we did last week. So, final 5-10 minutes, okay? Probability. Probability can be used as a scale, and it goes from 0 all the way up to 1, or in words, impossible up to certain, using unlikely, evens, likely, and certain. Okay? Only use words if they ask you to use words. Generally, they'll write the words down and get you to circle the word that they're interested in. So, if you get a question about rolling dice, flipping coins, and it asks you for a probability, okay, don't write evens or unlikely or likely. Write down 1/2 flipping a coin, 1 out of 6 rolling a dice, or whatever the probability is. Okay? People are dropping marks on their homework in exam papers writing down these words. Don't write them down unless they ask you for words. And it will say block capitals, bold words. Okay? So, probability. We know we've got words, but we use fractions, decimals, and percentages to represent probabilities. Okay? And the probability of anything always adds up to the number 1. So if I say to you the probability of rolling the number 3 on a dice is 1 out of 6, then the probability of not rolling a 3 is 5 out of 6. Okay. To calculate a probability of anything, whether it's simple flicking coins, rolling dice, to picking coloured balls out of a bag and socks out of drawers and whatever, it's the number of things that we're interested in, the outcomes we want, divided by the total number of outcomes that could possibly happen. Okay? So the probability of flipping a heads on a coin is 1 that I'm interested in divided by 2. Probability of rolling a 3 on a dice, okay, is 1 out of 6. Probability of picking a clubs out of a deck of cards is 1 suit out of 4 possible suits. Okay? So it's very straightforward whether you're dealing with those set probabilities or unequal probabilities. So if you had your bag of sweets and it's got 6 green, 5 blue and 4 red sweets, and I say what's the probability of picking out a blue sweet, you would say, what am I interested in? 5. What's the total number of outcomes? 15. Would you leave it like that?
No,
You can simplify it and it becomes 1/3. If you get a fraction, simplify it. Have a close look at it and simplify it if you can. Some of them won't. Okay. If you get multiple events, 2 spinners, rolling 2 dice, flavours of chocolates and that sort of thing, have a structured method for getting all of the combinations if they ask you for all of the combinations. Generally do it in a 2-way table where you've got white, dark and milk chocolate, and then your flavours of orange, coffee, strawberry, raspberry, and do it in a systematic way so that you do not miss anything with respect to the various combinations. And then they'll ask you a simple question about those combinations. This is very, 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 very popular. Rolling 2 dice and the outcomes from dice. They like it because the outcomes are not equal. Okay? If I roll 2 dice and I say, what's the probability of me getting the number 2, or a total of 2 when I roll them, it is, how many chances are there of getting 2? 1. So that's what I'm interested in. And what do I divide it by? 36, because there are 36 possible combinations. And they love these types of questions because they can ask you what's the probability of getting an 8, what's the probability of getting a number less than 4, what's the probability of getting over 5, and they can do it for fates, garden fates or whatever, or it could be just straightforward asking you, Just remember, whatever it is over 36. Okay? This is the tricky bit on probability. And that is that everything we've done so far on probability is to do with stage 1, which is I haven't rolled a dice or flipped a coin yet. I'm actually working on the theory, a theoretical probability. So the theory of me flipping a heads is 1 over 2, or a half, okay? 0.5. The expected frequency is this thing where if I flip that coin 50 times, I haven't done it yet, how many times would I expect to see heads? If I flipped it 10 times, how many times would I expect it to see heads? So if it's a half it's going to be heads, then it's a half times 10 that gives me 5 times I would expect to see heads. And that's what we call expected frequency. Still haven't done anything. If you do something, you'll do it through an experiment. Okay? And an experiment is doing something to prove that theory right or wrong. So if I flip the coin 10 times, but it lands on heads 3 times, then there's obviously something wrong, or there's a difference between my theory and what happens in my experiment. And we call that relative frequency. Okay? So the relative frequency is what do I see? I saw 3 heads out of 10 coin tosses, so 3 over 10 is 0.3, and I was expecting 0.5. And you can talk about it and compare it and discuss it. Okay? What would make that better? How could I improve that experiment?
Roll it 10 more times.
Yeah, flip the coin 10 more times, or what about 100 times? Or 1,000 times? Yeah? The more you do an experiment, the better the information. Does that make sense? Yeah? Okay. The last part, okay, on probability was about relative frequency graphs. You might be asked to work out relative frequencies of coin tosses, of dice rolls or whatever, and that's just dividing what you saw by the number of times you did it. So if I saw 1, 2 in 10 rolls, it's 1 divided by 10, which is 0.1. And you plot your number of rolls or throws and against your relative frequency. And we plotted one of those graphs last week. Okay. But the important thing to remember about experiments is the more times you do something, the better the information. Okay? If an experiment is repeated, the outcomes are going to be different. We saw that last week when you all rolled your dice and we looked at your graphs. Every graph was different. Okay? And experiments have a lack of memory. If I have 5 coin tosses and it goes tails, heads, 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 what's the chance of it being tails on the next flip?
50-50 still.
It's still a half. Okay? 1 over 2, 50%. Be careful about 50-50, because that's not a probability term. 1 over 2, a half. Don't use the word evens if they're asking for a probability. Was that my phone? Just quickly. Okay. Don't forget the Unit 2 basics. Numbers, fractions, decimals, percentages, okay? And ratios and proportions. Because they can be in there on their own. And they probably will be. So, top tips for today. Use your calculator. It's a calculator allowed paper. If you haven't got one, I'll loan you one. But do start bringing your calculator along and getting familiar with it. Okay? However, following up to this, use your calculator. And believe me, some people in the papers I've marked so far are not adding simple numbers together correctly. Like 2 or 3 numbers, like 8, 6 and 4, and coming up with 30, and you're thinking, what? Okay, so use your calculator even for the basic stuff. But show all of your working out. So if it says work out the mean, and there are 3 marks for it, don't go tap, 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 6. Because that's 1 mark. Show them that you're adding these numbers, it equals 40. Divide it by 8, 5. The answer's 5. And you've broken it down into stages. So even though you're using your calculator, make sure you show all you're working out. Look at the marks they're giving away. Draw your diagrams in pencil. Okay, use a ruler if it's a long line for a graph or whatever, or a pie chart, but don't waste time shading things in or whatever. It's 54 marks in an hour. It goes really quick. Attempt every question. Only a few people over the 50 or so I've marked so far haven't bothered answering a question at all. There should be no reason why you can't have a stab at a question. Give it a guess. Put something down. You might luck in. You might just hit on a couple of numbers that they're looking for that's associated with the marking scheme. Okay? I've got the marking scheme for this. I know how I can give you marks. I'm trying to give you every mark you can get.